now I will just share my screen um, on what we do and what is the achievement we have done so far. So I think my screen is shared and you can view that.
Yes, sir. It is visible. Visible, sir.
Oh, okay, sir. Okay, sir. Thank you. So to say this is our institute, Indian Institute of Food Processing Technology. It was under the Ministry of Food Processing Industries, and we have a license office at Guwahati and Batinda, Punjab. So we are operating from Thanjavur and all other areas of covering all over India. So next is we stand 74th rank. We obtained 74th rank in NIRF ranking in 2020 among the all the engineering colleges in India. So that is a food processing technology as only one subject we deal, and we have achieved this much ranking, and that is a greatest achievement. And about our institute, we started in 1967 as a small laboratory, especially addressing the paddy processing and saving the grains because of the rain hit. Usually in delta districts of Tamil Nadu, we coincide with the rains and the harvest will be coinciding. So that a lot of post harvest losses in the paddy. So to come over that, we did a we started with the laboratory and saving the grains, and then it was renamed as a paddy processing research center in 1972 and was shifted to Tanjavur. It was in Thiruvarur and it was shifted to Tanjavur, and then now it is being Indian Institute of Food Processing Technology. And in future, I think within 6 months we will be getting an institute of national importance where it will be standing like an IIT's separate institute. So we have been given a lot of awards, especially for the women's skill development and other things. So we have a lot of departments as well as the food engineering. We mainly concentrate on food engineering and food packaging systems, food product development, food safety and quality testing, food biotechnology and primary processing and storage handling, and technology dissemination, academic, and we provide BTech, MTech, and PhD in food process engineering and food science and technology, and food safety and quality control. So all other things are service industries like incubation, modeling, and monitoring, planning and monitoring, and academic cells. So our activities, first we started with the paddy processing, and in this one we have done with a lot of farm gadgets for the saving the grains, and then parboiling system. We have developed a lot of parboiling system. Almost in India, we can say that all the rice mills are one or the other way they adopt our technologies in processing the paddy, especially in the parboiling system and quality control of this parboiling. This parboiled rice and paddy and rice quality has been some of the standards has been set up by our institute, and this is followed by the Food Corporation of India. And we are doing a lot of work with the Food Corporation of India for setting the staff. So, for example, if the Food Corporation of India is procuring paddy from the farmers and giving to the millers and get back the rice in the form of a rice. So, what is the percentage of rice that has to be obtained? This standards has been fixed by our institute. So we have done all over the India. What are the standards? What is the quality of the paddy, and what is the return yield of the rice? So we have fixed that standard, and it has been accepted by the millers as well as the farmers as well as the government. So based on this only, we are fixing the public distribution system of rice. So next aspect, non-destructive quality analysis like acoustic resonance and soft X-rays, computer vision, NIR, spectrophotometer, e-nose and e-tongue, and sensory sensors and test kits. So I will come back to other things. And non-thermal processing is mainly we are focusing on electrospray freeze drying, disinfectants, UV disinfectant, and pulsed light treatment, and plasma processing, and ultrasound treatment, and ozone treatment. So this among this one, ozone treatment is more familiar with the like a turmeric processing, where the grains has to be maintained. But when you give a chemical treatment, it also impacts the nutritional value of the turmeric. So that ozone treatment we have adopted, and this one has given a very critical results, where it kills the larva and egg inside the turmeric rhizomes. So when you fumigate it, the fumigant doesn't go into into the rhizome, but ozone is only the splitted activated oxygen which goes into the rhizome and then kills the even the egg and also that larva inside. So this is an advantage which we have done it, and then we have standardized the process what at what level we have to give. And plasma processing also, I think yesterday we had a lecture from Uday Anapur, right? And he is a master in plasma processing, and we have also set up plasma processing. We are doing a lot of work on plasma processing. And grain storage technology, we have evolved and mastered the grain storage technology, as well as for the bulk storage and metal silos and hermetic storage and cap storage and alternative. These are all the things adapted in the industries, and also the food corporation India, where the bulk purchase of the paddy or the grain, food grains are handled. So we give a lot of technology. For example, if you say that bulk storage in metal silos, this is coming up very well in all over the India. And what happens inside the silo when the grains are stored? So that is the question, where how the heat is being transmitted, and how to reduce the moisture, and what are the steps we have to take to prevent the spoilage of the grains. So these we have a entire system of sensor. We have placed a sensor where the information will be, you will get through your mobile, and what is the technology, what is the alternate to save the grains, that information also will be received by your mobile. Like that we have given, and this is adopted by the Food Corporation of India. And now this is the technologies what we have transferred to different end users like mobile food processing unit, grain puffing unit, province, and idli mix, and a lot of other products. So if you see this, what are the technologies we have transferred? Mainly, it is like mission mode technologies we are working, and Nira tapping. I think you would have heard about the coconut Nira, or the sap that is collected in the coconut tree, and it is, the shelf life is very poor and very short. So if you say that once that Nira has been extracted, it gets fermented within 4 hours. So that we have to preserve that Nira, which is an energy drink, or which can be converted into a nutraceutical drink. So for what are the steps we can take up for the nutraceutical drink and energy drink, we have done it, a lot of work on it. And non-dairy millet ice cream, non-dairy coconut ice cream, and banana juice suspended with basil seeds, Nira sugar crystals. Nira sugar crystals are low glycemic. They are low glycemic. Normal sugars have an high glycemic index, but here Nira crystals have a very low glycemic index. And radio frequency dried moringa leaf powders. The moringa leaf, as you know, now it is becoming a superfood. So all over the world, it is being recognized for its protein content, vitamin C content, and its fiber content, which is having a very typical formation, like a fiber and protein combination is a very rare combination in the food sector. So these have a very excellent product and can be consumed in a different forms. And India is leading in the production of the moringa leaf, and then a lot of small businesses have been developed based on the moringa leaf itself. And now we have in our website also we have put how to process the moringa leaf drying powder, and then all the technologies has been freely being, you can download and you can see the process machineries and all the usages. And now this is the mobile processing unit. So we would have experienced when there is a lot of production in the tomato or onion and some other vegetables, they throw away in the field because it doesn't match the transportation cost, and then it is not giving any profit to the farmers. So they leave it as such in the field. So to come over that difficulty, we developed a process with a mobile processing unit where you can process onions, tomatoes, and grape. All these things we can process in a mobile processing unit. That it's an self-contained mobile unit which we have given to the government of Tamil Nadu. 4 units has been given, and it is working in Tamil Nadu. So I will show you that pictures also how we have made that. And small onion processing unit. And think in Maharashtra is more famous for the Bellary onions or big onions. But here we have a small onion which is more familiar and more suitable for making the sambar. Sambar is a traditional food in South India, and small onion is the major thing flavor component in the industries. and virgin coconut oil and small onion garlic baking unit and rice ice creams, rice health drinks. So these are the things which we have done, and then we have approached the mission mode project. This mission mode project is we go to the field, farmers field, and what is the difficulty, and what are the harvesting post harvest stages, what are the difficulties they face. We analyze that and then we give the solution for that. So these are the things which we have done. See, we first went to the farmers field and we analyzed what are the difficulties, what are the technical problems they face, and we formed a group with the farmers. Perambalur, in Tamil Nadu, there is a Perambalur district which is in the center of Tamil Nadu, and they are the major producers for the onion, small onion production area. Near about 8,000 hectares of onion is being produced. So this they had a lot of difficulties like root cutting and stem cutting and peeling. All these process are very difficult for them. So we evolved with some technologies for easing the process, and the machineries that has been designed and developed should be matching, and it will be easy, affordable to the farmers, and then it is easily operatable by the farmers. So that was the objective. We were very clear in keeping that, and then we coordinated with the Tamil Nadu Agriculture Marketing Board, and we set up an incubation center. And based on the incubation center, we developed some of the products which are more marketable products and we have a link up with the market people like Amazon and other things. So it was easy for the farmers to process their produce in their own field, and then produce the end product can be transported to other areas of the industries. So this is the incubation center what we have set up in Perambalur, and these are some of the machineries which we designed for the for particular uses of the onion, small onion. So these equipments what we have developed is onion stem and root cutting machines, onion peelers, and onion curing and come storage textures. And we have developed products like vacuum packed peeled onion, fresh onions. The fresh onions cannot be stored for a longer time. So once it is peeled, it has to be preserved in a vacuum packing machine, and then it has to be stored at lower temperature and be transported. Why we want to do the peeled fresh onions? These are the major ingredients for the sambar, as you told. And a lot of hotels are using manpower, a lot of manpower for peeling the onion itself, because this is a very small thing, and peeling the onion itself is a very drudgery work. So we have developed a machine where it can peel around 10 kgs of onion can be peeled in an hour, and then this can be distributed or processed in different forms. So if you see this on, I can show this video. Are you able to see the video?
No, sir, not yet.
Yeah, wait. No, it's not coming, but I think it is not coming. Okay, no problem. I will. Okay, I'll just skip that one and I'll stop it as you are not able to see the video.
So it's on the website IIFPT, so they can
Yeah,
see
it's
on
in
the.
the website. ISPT website, it is there. Uh, so next is So these are the products which we have done with the small onions. So the shelf life, everything was set up, and then the farmers were able to handle that. So what is the advantage of doing an incubation center at at the village level, and then how it is being marketed? Say, for example, if you want to transport 1 kg of any of the crop to a particular distance level, the carbon footprinting is very high, and the petrols and all the fuel used for this one and manpower involved in it are very high. But when it is converted into a value-added products on the production area itself, and then it being transported to other areas, it becomes very easy for the end users as well as profitability for the people. And then the byproducts which they are obtaining out of this processing or can be used. For example, if we if that onion peel, which was a very valuable nutraceutical component that we extracted, and then this extraction was used for some other cosmetical industries. So that is still further value addition. So that this gives an more than the double income to the farmers. That is the achievement what we have done. And the next mission process what we have done is with the coconut processing. So coconut processing is coconut tree. Everyone knows what is the difficulty in it. So when the sap has to be extracted, the shelf life is very poor, and then one manpower is regularly needed to climb the trees and come down with the sap and then transport these things. These are all the difficulties which we have analyzed, and then we have done with some technologies where the sap is extracted through a machine equipment which was designed by our institute, and then collected in a cold storage tank and transported to a processing unit, and made into a tetra pack and bottled in a safer manner to extend its shelf life. So that at an average, we can extend the shelf life of this Nira in a cold storage structure with more of sensory quality, with very good sensory quality, up to 15 to 20 days. So this was the achievement, and then there was a regular income for the people. They are getting a lot of income from the for the sap drink. If it is fermented, it becomes like a toddy. It becomes a fermented alcoholic drink. So that is not permitted in Tamil Nadu. So that we have developed a system to reduce the alcohol content, and then save it as a Nira itself. And then this can also be converted into vinegar and all other byproducts and products of this Nira products. So these have a very excellent marketing skill and export opportunities for the industries. If suppose if the Nira is there, more of a Nira is obtained, that can be converted into sugar crystals where it have an higher income, as the crystals are very low glycemic. As I told, it is a low glycemic. So what are the difficulties in coconut processing is sorting and grading. We cannot even, you can say that size grading is different, but sorting and grading, what is inside the shell, we cannot even see what is happening. So that one was the sound acoustic resonance technique was used here to sorting and grading, and deshelling and pairing machines were mechanical things, and coconut water collection. Once the coconut, for example, if you take in some temples in South India, they used to break the coconut, and the water is going waste, and it gives a lot of nuisance smell to the area premises. So we have developed one collection on equipment where you can break it is placed in the temple itself. You break the coconut, and the coconut water is sucked inside and then filtered, and then made into a prasad. It converts into a tirtha and then given to the public. So it is not wasted. Same time, it have a very good quality of sugar, and many other value-added products can be done. But it is only given now. It is only given as a prasad. Okay. So sensory for the quality, oil quality evaluation, and copra dryers. So to extract the oil, the coconut has to be dried. The moisture has to be reduced with safer level without any fungal growth inside the coconut, and then the time taken for drying is very high. So that we developed a solar copra dryer, and it is also in our website. We can see, and this is the machine where we have set up. It can be fixed in the coconut. You imagine that this is the coconut tree, and here the machine is fixed in the coconut sap area, where this is the area, and then sap water is collected in a collected down and in a storage tank in the bottom of the tree, so that there is no need for a man to climb up the tree, and then all the machine is an automated machine where it does all the work of a man who wants to go and clean that sap and other feathers, so that it can automatically do at once in 12 hours. It will automatically do its work, and then near a tapping machine. So this is the tapping machine which we have developed, and this one is the after Nira has been tapped, this Nira is converted into sugar crystals. So if you see the comparison of the crystal formation of this Nira, it is having a high potential nutraceutical components, so that it can be used for the medicinal purpose as well as for the normal sugar. So it has a low glycemic. So this is another equipment which was developed by our director, Dr. C. Ananda Ramakrishnan, who is developing an auto, and it's a dynamic stomach model where you can assess the glycemic index without any animal testing. So this is a mechanical model of the engineered gastric model for small intestine system, and this is one of the system available in the Asia. And we were able to go in for a lot of projects which we have collaborated. And one of the collaborative was Siddharth Starch in Pune, and they are producing a lot of potato peels. So these potato chips, they are supplying the peeled potato to the PepsiCo. So they have a lot of issues on the environmental pollution of the cleaning and washing the potato peels. And these peels have a high protein content and minimum of starch. So these are all agro waste. So we want to address this agro waste into convert it into value added products. So what are the value added products and what are the industries? We assessed what are the industries in India. For example, pulse industries. If you say in Maharashtra, there are a lot of pulse industries, especially in Pune, Aurangabad, Jalgaon, all these areas we have a lot of pulse industries, and a lot of pulse byproducts are obtained. So these contains more of a protein, and pomegranate it is also in Maharashtra. If you see that pomegranate growth is very high, and then they have a national research center for the pomegranate in Maharashtra itself, and then these are the agro waste, grape waste. So these things we converted into extracted the valuable components from that, and then added into the food products, and it is being supplied. Now we have linked up with the PepsiCo in UK, and they have come up with different products. We have extracted the essential components and then managed to incorporate into different products, and these products are being supplemented, so that cost of it is very less. The cost of it will be very less, and utilizing the agro industries waste we are utilizing, and in a safer manner. And it should be safety is a major concern, and we are working on the safety as well as the quality of the products that should reach the people. And this was designed for a midday meal scheme, for a scan, for like we are giving a snack foods for the children with more proteinaceous and more nutrient enriched snack foods for the children. So this was planned here, and then we have done a lot of work on this. So next is soya milk, soya microwave assisted extracted soya milk. We instead of heat energy, we have used a microwave assisted solar. You can see this microwave cooker, and inside that we have put a bowl where that soya milk is given, and which leads to reduction in the anti-nutritional activity in extracted soya milk, and we can make a lot of dairy analogs from the soya milk. So it enhances the quality of the soya milk, and then storability and the taste change. The flavor change is obtained, and then we can change it to converted into very other lot of value added products. So this is another design and development of solar photovoltaic powered cold storage system. So all the villages, all the farms cannot have all the sufficient electrical system to support the cold storage. So we developed a cold storage system along with the National Institute of Technology, Tiruchirappalli. They developed the solar system for converting the energy into cold storage system, and then we tested with the different fruits and vegetables, and then we can develop a small on-farm storage system or it can be mounted in a vehicle where from the farm to the market it can have a very good quality of fruits and vegetables can be stored and then can be distributed. So this is the objective of this project and we have done it. And major things is ready to eat snacks and composite flour from the food industry waste, what I told with the nutrition project. So we termed it as a nutrition because generally nutrition is NU, but here we have given a new NEW. So if you see this one, these are the major industries as I told in the nutrition project, and we have collected all these materials and then analyzed all this phytonutrient fiber, what are the components is it contains, and how it can be utilized for the different things. So potato fines is a promising candidate. We can replace partial the wheat flour and add into the wheat flour for making chapatis, cookies, and steamed idli. Idli. So we aimed for two components of the South India, one for the South Indian thing and another for the North Indian breakfast cereal. So one is chapati in the North Indian and South Indian we did with the idli. So this is an optimized. Actually, these are all the agro-based products, and we added and converted that into a value-added products and supplemented, incorporated into different regular meal. So these are the success stories of our project on that. And next aspect of jackfruit, I think in Maharashtra, Goa, and Karnataka, you can see that a lot of jackfruits are available. But in jackfruit, what is the issue is that we are only consuming 30% of the jackfruit. Jackfruit means only the bulb we are consuming. If you take one fruit, in the bulb only we are consuming. The other parts we are throwing away or it is not utilized. So we are trying to utilize all these things at a single phase of a thing. So how we are doing, segregated all the fruits and the different parts of the fruit and then made it to a small flour and combined this flour into a different composite flours and then this made different products have been developed. So bakery products. And why I want to concentrate on this jackfruit and jackfruit products. So these have a high fiber and low glycemic and diabetic and all other people can be used like can be consumed and lot of nutraceutical components are there, nano fibers and nanotechnology, and then these are all the common usages what we have developed. Some edible plates, ice cream cones, and pasta products. All these things have been developed from this single component. And this is the waste utilization of the onion peel. So other innovative products what we have developed from our institute is non-dairy coconut ice cream. So coconut, generally ice creams we use only the milk. But whether we can use an alternate to the milk because of the lactose intolerance and other components. And what is the alternate use for this coconut things we tried and then we have done with an ice components are available. And if you say dairy, non-dairy millet ice cream is another major in the millet is upcoming, and then this is we consider it as a poor man's food, but now it is being becoming a very rich man's food. And then millet processing, especially in Maharashtra, if you say Nasik and Indore are the major millet processing unit, and from here in Tamil Nadu, we are sending the millets to Indore and Nasik for processing the millets, further processing of the millets. So millets are excellent components for making an ice creams. So millet dairy. Generally, we in childhood we would have experienced our grandmother or would have given a sprouted millet ground into a small. The starch is extracted, sprouted grains, starch is extracted, and then this is the first weaning food they consider. But here, the same technology has been used as a weaning mix and then converted into a ice cream flour. So sufficient good quality fat like omega-3 from the chia seeds and other things added and then made into an ice cream. So this gives a value addition to the millets and then it gives an popularity. Because why we want to sell, most of you may think why we are concentrating on the ice creams and other things, why we cannot use other things. Other uses are there, but ice cream and things are very it's an universal product. It can be easily taken up as a business itself, business model. So that is what we were concentrating. And millet based functional cookies, I call it as a functional cookies because it's a creamy biscuit where in the cream, this cream is also a part of a millet starch, which is combined with the is the lactobacillus, the microorganism that has been used here to ferment the millets, is a very critical thing, and it has been patented. And if you see this mahua flowers are very famous in Bihar, Madhya Pradesh, and some parts of Maharashtra, Chhattisgarh. These mahua flowers are used for the fermenting. The seeds are used for the fermented drinks, and it's only alcoholic drink they use in the tribal people. But it have a very good components of micronutrients and other things. So and we combined with the moringa leaf and mahua and made it to a bar, nutri bar, which is supplied for the defense people. For why this mahua and moringa has been given is because of its iron content, protein content, and the gives a diuretic and an analgesic characteristics of this mahua combined together. And with the chia seeds, it gives an excellent nutritional energy bar. So we developed a bar which contains around 450 calories. So 450 calories means one soldier, for it was given for the defense people. It was in the soldier in remote areas in cold climate. They want little bit of alertness. This alertness is being given by the mahua flowers. It gives the given alertness, and then this is iron supplement, because iron is major thing for the thermogenic characteristics of our body. So it's a thermogenic food. When we consider this is as it's a thermogenic food, because iron, when there is a more of iron, it's a very simple technique for without blood testing. You can test your thing. If you sit in a AC compartment for a particular time and exposed to all the people, different people are exposed in controlled at temperature. Some people feel cold chillness very quickly. So if you see that, their iron content will be lesser, hemoglobin content will be less. So the next aspect is the carbonated drinks. Carbonated drinks, as you know, Pepsi and Coca-Cola, all these, lot of companies are there, and soft drinks are being prepared. Only sugar, high concentration of sugar and carbonations, and plain water. That is all. But what is the nutrient content in it? There is no nutrient content. So we came up with an guava fruit pulp, and then added with the water up to 15% of the guava fruit was acceptable, and then was tastier and more with antioxidant and low carbohydrate, high fiber, and more protein. So this is the concept what we have developed for the carbonated drink, and this is one of the pet project of our institute and our director. And this one is the 3D printing thing. This is like personalized nutrition. Say for example, if you want high protein or high fiber, or if you want a little bit of high immunity boosting components, you can design that things, and the particular nutrient can be kept as a printer in a printing cartridge. You can keep different individual nutrients and then mix up with this and make as a product, and then use consume as a thing. So this was first planned for the Anganwadi children, where the children are deprived of protein and micronutrients. So for that, we designed a machine where you will be supplementing with the required nutrient, and can be given to the children when they go out of the school. Just when they leave the school in every day, they can print their own food, and then they can take it. That was the concept which we developed on this one. And these are the people who have been uh, startups, and we have given the skill development sector, and then we have given skills and starting the industries itself. And we saw a hand holder all these people, and we have an incubation center with all the facilities. Like they can come with their produce and then process it in different end products. We guide them in getting the license, processing technology, what are the machineries they need. All these things we help them, and then they can use our incubation for the 6 months, first 6 months, and then until they are confident of operating their machines. So that until then they don't want to invest in the machines, they can use our facilities and then go on. They only pay the electricity bill and the usage of the machines, very minimal charges. So these are the products which we have developed from our incubation center, and a lot of capacity. What is the capacity of our incubation is around 50 to 500 kgs of different products can be done, and turnover is 3,000 to 10 lakhs. Different incubators have gone excellent turnover, and they are exporting to different countries and different states of India. And you can see that how many people are employed. So this is what the benefit of having an incubation facility and training them. And we used to conduct one day, an open day, where the public can experience what we are doing, and they can observe what are the machineries, how they operate, and they can enjoy the products that have been developed instantly from there in their, just like a touring. They can come and take it. And we last time, because of the COVID, we are not able to do, but last time we did around 10,000, more than 15,000 people attended this program. And this is the mobile processing unit. A lot of we are sending this equipment, this mobile processing unit throughout India, and once it has also visited Kolhapur also. This along with the vehicle, we came for the processing of tomatoes, some of the products which we did demonstrated there. And this is a mobile testing unit. So food testing is a very big challenge for the small industries. So when they want to test it, they don't want to bring the sample. They will go there and test the sample according to the FSSAI standards and give the reports then and there. And they have to pay a minimum amount. So these are all inbuilt with all the energy sources, everything, working conditions, everything is there, backup. And this is the mobile processing unit. So there are a lot of opportunities in the food processing sector, as the ministry has given a lot of inputs in this one. Now I will stop here, and these are all the website of ministry. So thank you for all